Find volume by discs/washers homework. We're going to look at problem number 1 here, and parts of these are going to be pretty easy. Conceptually, it's going to be the same thing we've gone over recently in class. Here we have find the volume if the region enclosing y equals 4 minus x, x equals 0, and y equals 0 is rotated about the, and we get different choices here. So anyway, we're going to look at the x-axis first of all, and we have the function or equation y equals 4 minus x. Well, I hope you can see that this is a linear function, 4 minus x, with the y-intercept being up here 4 units above the x-axis. So here 1, 2, 3, 4, and so and the function itself has a slope of -1. So the function itself is going to be left to right, downward, diagonal till we touch the x-axis right here. All right, and then having touched the x-axis, we have this area above, and we are rotating about the x-axis according to instructions. So it's going to go like this, and if we rotate and we continue looking from the straight ahead view, we're going to see this. And as we view a rotation either from the left or from the right, okay, let's look from the left side. What are we going to see? We're going to see a circle. But R, big R in this is going to be this function right here, y equals 4 minus x. So we put this down as big R, 4 minus x. And little r is going to be right here, this y equals 0 right here. So that's going to be 0, or equals 0. And so our volume is going to be our pi times, and what are the x values we're concerned about between x equals 0 and x equals 4. There's 4 on the right. So we're going to say from limit 0 to 4. And we're going to have big R, and big R is going to be 4 minus x squared minus little r, which is 0, of course, squared. And then we have dx times all that. So we work this all out. And on these exercises, I'm looking for the correct setup, and if we plug these into a calculator or work these out, we would get the right answers. So we're really looking for the right setup and not really beyond that. B, the line y equals 4, and so you're really talking about the same drawing. What I'm going to do here is kind of change the axis of the graph, of the coordinate plane. I'm going to draw, we're looking for y equals 4. So we're going to take our x-axis down here. We're going to say this is going to be 0, 0, and we're going to go up 1, 2, let me make it smaller than that. 1, 2, 3, 4. Okay, and there's y equals 4 straight across here. Okay. And right at the bottom, that's y equals 0. And then what we have is the same function we had earlier, which is going to be this x minus 4. Okay, now I'm sketching that in blue. Okay, there it is, sketched in blue. And the line y equals 4 right here. Okay. And so the shape that we're looking at is this one right here. Oops. Well, it's the same one we drew earlier. Remember we drew that one in purple? I'll draw this in blue. And we're going to take this and rotate it around the line, the axis y equals 4, and then reflect it on the other side. The thing's going to come up like this, and this is what the thing is going to look like above. And again from the side, so this would be a side view, and actually from front view, and from the side view we're going to see, as we have before, a circle. Well, in this case, our big R, okay, our big R is going to be this distance between the x-axis and y equals 4. And so in this case, big R is equal to 4. And little r is going to be our equation, which is going to be 4 minus x. And so our volume is going to be equal to pi, limits from 0 to 4, and we're going to have big R, and big R is 4, so I'm going to put open parentheses 4 minus little r will be 4 minus x squared. Oops, I forgot big R squared. That 4 will be 4 squared. Okay, big R squared, that's 4 squared, minus this squared dx. Okay, so that's going to be this one. Alright, now next one, the line y equals 5. Alright, similar type of setup as the last one. We're gonna say 0 is right here at the corner, the origin 0, 0, and then we're going to go up, in this case, 1, 2, 3, 4, 5. Okay, so our axis rotation in this case is going to be y equals 5, and but the function is the same. So we're talking about this shaded purple area. Instead of rotating it right around y equals 4, we're rotating it around a bigger radius of y equals 5. So this can be very similar, except the distance are going to be different. In this case, big R is not going to be 4. Big R is going to be the difference between the x-axis and y equals 5. So our big R is going to be 5, and our little r is going to be the same as we had earlier. It's going to be, well, it's not going to be 4 minus x. It's going to be 4 minus x plus 1, because we have this distance of 1 more from the function to the line y equals 5. So we'll say plus 1. And I'm going to just simplify that out. It's going to be 5 minus x. And so when we take the volume, we're going to have pi times, from limits from 0 to 4, of big R, which is 5, squared, minus quantity 5 minus x squared, and dx. So that's going to be that one. Okay, and just completing the drawing above, the thing on the other side is going to look like this. Okay, so these shapes are separated as they turn around. Okay. Next, D, E, and F have to do with about the y-axis. What we're going to do is take this equation, which is y equals 4 minus x. we're going to be doing things with respect to x. So we're going to solve this equation for x. And solving for x, if we subtract 4 from both sides of the equation here, we're going to get y minus 4 equals negative x. And if we just multiply the whole equation by negative 1, we're going to have x equals 4 minus y. So that's going to be our equation we're dealing with. And we're looking at essentially the same equation we did earlier. So when we graph that equation, it's going to look like the same way our first one looked like, right above it. A, it's going to look like this. I'll make that a little neater if I can. Okay.